marginal and conditional distributionals. Okay, this is great. 3 balls are randomly selected from an urn with 2 red, 3 white, and 4 blue balls. We've seen this setup before in a previous example, right? You're going to pick 3 balls from these. 1, 2, 3, 9 balls. Okay, and you're interested in knowing something about the number of red balls that you obtain in your sample and the number of white balls that occur in your sample of size 3. Okay, so we're looking at 2 random variables and how they behave together. One thing, we pointed this out before, but note that because you will only get red balls and white balls, that if you know the value of R and the value of W, then you automatically know the number of blue balls as well that occur in your sample. Okay, this is an important but simple little point here to be made, that that is that sometimes you don't need a complete picture. You don't need to track every single random variable in something that in a situation to know everything about it. Right? I can always recover the number of blue balls by taking 3 minus the sum of these 2. Right? Okay. So let's take a look at what can happen here. Across the top here, I've got the number of white balls that could occur in the sample, 0, 1, 2, or 3. I can see no more than 3 white balls because there are 3 white balls, and I can see no more than 2 red balls because there are only 2 red balls. Okay, and so we've worked out these probabilities before, but just to remind you, for example, the chance that you see no white and no red, that means all of them were blue balls. So there are 4 blue balls. 4 choose 3 is the number of ways to choose 3 blue balls from 4 blue balls. And then divide by 9 choose 3, because 9 is the total number of balls we have. 2 plus 3 plus 4 is 9. 9 choose 3. The denominator is the total number of ways to choose 3 balls from the 9 balls. Okay, so this gets us 4 out of 84. Similarly, let's do this one here. Like the total number of ways to get exactly 1 red ball and exactly 2 white balls. Well, let's see. To get 1 red ball, there are 2 red balls, so there are 2 choose 1 ways to get the red balls, and then the 3 white balls, and I want to know how many ways I can choose 2 white ones from the 3. So it's 2 choose 1 times 3 choose 2. Okay, and so forth and so on. You'll notice that of course there's no chance of getting 1 red ball and 3 white balls, because that means you're choosing 4 balls. Okay, so you can't do that. So that's impossible. That's a 0. Okay, so this is our joint distribution. But like from my right finger to my left finger over here and so on. Okay, and remember what a distribution does is it tells you all the possible. It tells you 2 things. It tells you all the possible things that could happen. Right, I've got those along here. Right, like this could happen. Or this could happen. Or this could happen. I could get 1 and 1, or I could get 2 and 0, or 2 and 1. It tells you all the possible things that could happen, and the second thing it tells you is all the chances of those things happening. Okay, all right. Our distributions tell us the behavior of random things. Okay, now out along the sides here, we've got something that we need to talk about. I'm going to draw a heavy. I'm going to put a bold line out there because this is something a little bit different. Over here, I'm going to put the row sums. I'm going to put the row totals. 4 plus 18 plus 12 plus 1 is 35. 35 out of 84. Over here, I've got 12 plus 24 is 36, plus 6 is 42 out of 84. And then 4 plus 3, that's 7 out of 84. And let's see, 42 and 35 is 77, plus 7 is 84 out of 84, which is 1. Okay? These guys over here are these numbers that occur in the margin of the table. These are together. These are marginal probabilities. Ha! That's why they call them that, I bet. Yeah. So this number is really, note that this number is really, this is the probability that R equals 0, right? If we don't even care about the number of white balls, this is just the probability that the red ball, or that we see 0 red balls, right? Because it's, look at what we've done there. It's just the sum of, it's the probability that red equals 0 and the number of white balls is some variable, right? But we've summed over all values of little w, right? So together it gives us the chance that the red ball is 0. Similarly, this one is the chance that the red ball, or that R equals 1, or that we see exactly one red ball. This is going to be the chance that R equals 2, right? And so, of course, these should sum to 100% by our third probability axiom, right? And they do. Okay, good. Similarly, guess what? This guy is going to be the probability that W equals 0, and this one will be the probability that W equals 1. This will be the probability that W equals 2, and this will be the probability that W equals 3. Let's get those. 4 and 12 and 4 is 20 out of 84, right? 18 and 24 is 42 plus 3 is 45 out of 84. And 12 plus 6 is 18. And just pick up the 1 out of 84 from up here, right? So 20, 65, 83, 84, yeah, these sum to 1 along the bottom there. Yeah, so good. So we've discovered basically what we mean by marginal probabilities. Okay, so this occurs all the time. Sometimes we know the behavior of random variables, how they behave jointly or together, but sometimes maybe we're just interested in the behavior of one of them, regardless of what's going on with the other one.